Hello, and welcome to the Electric Classroom. My name is Tom Sullivan, and in this tutorial, we'll shed some light on apparent power. Entitled Using Sullivan's Slide Rule 5.0, this tutorial demonstrates a simple method that I devised to approximate the apparent power of a set of MW and MVAR readings without the use of the Pythagorean theorem, squares, or square roots. It's subtitled Estimating the Hypotenuse of a Right Triangle because its use isn't just limited to power applications. In fact, it works for any right triangle. Familiar to anyone working in electric operations, the power triangle is a right triangle that visually depicts the relationship between the complex power, the real power, and the reactive power in an electric circuit. The term apparent power refers to the magnitude of the complex power, which is simply the length of the power triangle's hypotenuse. It is usually computed from a set of MW and MVAR readings using the Pythagorean theorem, but as you'll soon see, we won't be needing that anymore. We'll follow three simple steps as we approximate our apparent power value. First, using the MW and MVAR readings that we've been given, we'll form a power fraction. Next, using the decimal equivalent of that fraction and my slide rule, we'll find the associated approximation factor. Finally, using that factor and the base of our two readings, which is the larger of the two numbers that we've been given, we'll formulate our approximate MVA value. And I want to mention at this point too, that with just a very little bit of practice, you can learn to do this in your head. Let's jump right into an example to get a feel for this. Step one, we start with a given set of readings, in this case 40 megawatts and 16 megavars, and we'll use those numbers to form a power fraction by putting the smaller number in the numerator and the larger number, the base, in the denominator. The base we'll use again in step 3. For now, we have 16 fortieths, which we'll simplify to 4/10 and then convert to a decimal, which in this case is 0.4. The next step will be to slide that decimal along the upper portion of the slide rule from left to right, starting at 0. In this case, we'll get past 0.32 and about halfway to 0.57. We find that's where our 0.4 belongs, as is shown by the green arrow. Once we've done this, we now look on this lower scale below the green arrow and read what our approximation factor is. And in this case, it's 1.1. We'll use this in our next step. Our third and final step is to determine our approximate MVA value. In order to do this, we'll multiply our base, the larger of the two numbers in our set of readings, in this case 40, times the approximation factor that we got from the slide rule in step 2. So 40 times 1.1 gives us 44 MVA as our apparent power approximation. Now, were we to use the Pythagorean theorem to solve for this example, using 40 and 16 as our values, we would get 43.1 MVA. Pretty close to our MVA approximation generated by using the slide rule. which, by the way, is always within about plus or minus 5% of the value that the Pythagorean theorem would give you. Now, the next 8 slides are 4 examples and their answers to give you a chance to practice using this method. So here's our first one, 15 megawatts and 3 megavars. To help you along a little, I'll remind you that you start by forming a fraction, putting the smaller number in the numerator and the larger number in the denominator. Once you have that fraction, you simplify and then convert it to a decimal. Do you remember what step 2 is? You take your decimal value and you slide it along the top of the slide rule to see where it fits. And wherever it does, you look below that point to find your approximation factor, the one you'll use for your calculation. In your final step, you'll multiply that factor times the base, which is the larger of the 2 numbers, in this case 15, to get your answer. All right, are you ready to go to the next slide and check your answer? Did you get 15 MVA as an answer? Congratulations if you did. If you didn't, that's okay too. The first time through anything can be a little bumpy, so we'll go through it together. And hopefully you'll see the error of your ways. All right, step 1, we form a power fraction with 3 in the numerator and 15 in the denominator. Next, we simplify that, in this case dividing both numbers by 3 to get 1/5, and then we convert it to 0.2. With our decimal value in hand, we go to step 2, where we slide that 0.2 value along the top of the slide rule, starting at the left at 0. And in this case, you'll see where the green arrow is, 0.2 is going to fit about halfway between 0 and 0.32. So we stop right there, and we look in the box below to get our approximation factor, in this case 1.0, or simply 1. Now in step 3, we use this factor of 1 to multiply times our base, the larger of the 2 numbers, in this case 15, and we get an approximate value of 15 MVA as our answer. If we had used the Pythagorean theorem and plugged 3 and 15 in, we would have gotten 15.3. So in this case, our approximation is within about 2% of the actual calculated value. And remember that using this slide rule, which I call Sullivan's slide rule 5.0, the approximate value you'll get will always be within about plus or minus 5% of the actual value. All right then, are you ready to try your second example? All right, here it is, 27 megawatts and 18 megavars. And I'd like to mention right now that you would get the same answer whether it's 27 megawatts and 18 megavars or 18 megawatts and 27 megavars. It doesn't matter. We're just looking for the length of the hypotenuse. All right, to give you time to work at your own pace, I'll ask that you pause this video right now, and when you're ready, unpause it to discuss your answer. Okay then, let's go to our next slide and check your answer. Did you get 32.4 MVA? Congratulations if you did. Did you get 32 or 33 because you rounded up or down? Again, congratulations if you did. And once again, if you didn't, don't worry. We'll walk through this one together too, and I'm sure you'll get it this time. All right, then step 1, using our supplied numbers of 27 megawatts and 18 megavars, we form our power fraction, 18/27. We then simplify, in this case 2/3, and convert to 0.67. So if you thought to divide by 9, you got 2/3 right off the bat. So now we move to step 2. With our decimal equivalent of 0.67 in hand, we start at 0 and slide along the top of the slide rule. This time we'll go past 0.32 and 0.57, maybe a little over halfway to 0.75, and we stop there. That's where I've got my green arrow for you, because that's where our 0.7 fits, 0.67 fits. And looking below that point, we can see our approximation factor is 1.2. Now in our third step, we'll multiply our base, the larger number, 27, times our approximation factor of 1.2, and we'll get 32.4. If you didn't bother to round off. But again, it's an approximation. If you got 32 or 33, that's probably fine too. Interestingly enough, in this case, our calculated value using the Pythagorean theorem is also 32.4, so it just happens in this case to be right on the money. Are you ready to go on? All right, here's your next example. Once again, in order to give you time to work at your own pace, I'll ask that you pause this video right now and then unpause it when you're ready to discuss your answer. Thank you. Wow. For a minute there, I thought I was going to fall asleep. Let's take a look at the answer. Okay, by any chance, did you get 42.9 MVA? Maybe 42 or 43? Certainly acceptable. And this brings up a point I haven't mentioned before, and that is that my intention here is to do all this without a calculator. And with just a little bit of practice, you can actually learn to convert your fraction to a decimal, and after memorizing the few numbers on the scale, you can come up with the approximation factor and multiply it times the base, all in your head. All right, back to our example then. In this case, we form our power fraction, dividing 27 by 33. And the easy way here might actually be to multiply both those numbers by 3 and get 81/99, which is very close to 0.81. And that's the reason that I have an approximate sign here instead of an equal sign in front of the 0.81. Now, if you want to use a calculator to get a third digit of 0.818 something, you could. But as you can see here, no matter which way you get that, by a calculator or just by approximating it in your head, you're going to end up in a spot where 1.3 is the approximation factor that you're going to use. And again, we're going to take, in our final step, we'll take 1.3, multiply it times our base of 33, and we'll get 42.9 MVA as a final answer. And as you can see here, our calculated value using the Pythagorean theorem is 42.6, so we're actually less than 1%. So that's a pretty decent approximation. All right, let's move on to our last example. All right, here's your last example. Once again, in order to give you time to work, I'll ask that you pause the video and then unpause it when you're ready to discuss your answer. Ready to take a peek at our last answer? Here's hoping that you got 70 MVA for an answer. Let's walk through it together. 47 megawatts and 50 megavars, and again, just to point it out, it doesn't matter which is larger and which is smaller. The answer is going to be the same, and the units for your answer is always MVA. In this case, we form our power fraction of 47/50ths, and I hope you see that if we multiply both numbers by 2, we end up with 94/100ths, which is simply 0.94. So pretty readily we blow right through step 1 on this one. And with our 0.94 in hand, we start on the left, the top of the slide rule, and we slide past 0.32, 0.57, 0.75, and 0.91, and we drop our 0.94 to the right of the 0.91, and we're in the last box for our approximation factor, as big as it can be, 1.4. And you multiply the 1.4 times your base, in this case of 50. 0.4 times 50 is 20. 20 and 50 is 70. So our approximation is 70 MVA. And again, if we used the Pythagorean theorem, we would get 68.6. So in this case, we're about within 2%. This ends my tutorial. I certainly hope that you've enjoyed it. If you're interested to take the online version of this tutorial, please visit my website at theelectricclassroom.com, all one word, and you can get to the Thinkific link to that online course. Also, I plan to soon be adding another course to that website, which will delve into right triangles and the Pythagorean theorem a little further, and also go into how I devised my slide rule in the first place. So check back for that too. Thanks again. So long.